Okay, so you guys talked about it. Okay, what makes it even function and even function? What makes an even function and even function?
Oh, it's able to reflect over the y-axis, like
Reflect over the y-axis, so if there's that, reflecting over the y-axis would be that, okay. Anya, what makes an odd function by looking at the graph? So if that's the odd function,
Doesn't it like go around the origin?
spins around the origin, so, something like that, I don't know. If you picked it up and turned it upside down, you would see the same thing. Okay, yes. Dora, algebraically, what were the things that had to be true for an odd function?
algebraically.
So f of what had to equal f of what?
Oh, f of, for it to be even?
For it to be odd.
For it to be odd, f of negative x has to match negative f of x.
Perfect. So, if f of negative 2 is 3, what's the other coordinate that would be guaranteed? If negative 2, 3 is on there, turn it upside down. So the opposite of, so f of negative x, so the opposite of negative 2 is positive 2, has to equal the opposite of this guy. Yes? So basically, if the coordinate negative 2, 3 is on it, its counterpart, because it's odd, switch the signs. That one also needs to be on there. Stuart, what algebraically do we need to show if it's even?
It's even that f of x is equal to f of negative x.
So if f of negative 2 equals 3, even what coordinate do I know is on there, if it's even?
F of 2 equals 3.
So if f of negative 2 is 3, f of positive 2 is 3. If f of negative 3 is 5, f of positive 3 is going to be 5. Like, it means each step of the way they need to match up. Okay. All right, so today we're going to do a little bit more about even and odd symmetry, but the goal is to get to inverses. And a heads up that there's a test, most likely Tuesday next week. Need to see how many of the interruptions this week. There's a half day Friday. Stuff is gonna, if that interrupts things, but the goal is the test is Tuesday. Now we won't do that yet. So, with what we just did a second ago, Stuart said, for it to be even, this needs to be true. So if this coordinate, negative 3.5 and negative 2.5 means positive 3.5 and negative 2.5 will be on the graph. Okay? So this is how I took attendance in the last class. You guys need to get up and put a coordinate up. And once you find, like, I don't need to see the coordinate, written as a point, but cross off the one that you did. So, we're gonna do the even, which there's only 16 points, so only half of the class can come up and do this one. Odd is more difficult, so I recommend you get your coordinate put up there on the easier one. So I want you guys to come up, spot a dot. First come, first serve. Lizzie's gonna knock people out of the way. Angel gets there first. You gotta plot it on the other side. I love the crowding of the board. This is great. So try yours.
Yeah, and the other one is like, put it like on the other, like the opposite. They actually want. Put more coordinates lane. This is like, your emphasis this week being each other. And I'm like, it's like one of the last week, one of the last week. Who actually wrote the code? What a try.
Okay, so possibly all the coordinates are taken. So, well, let's see. So if we connected these, it it's kind of close. A little off, but the grid is hard to see. Does it look like it could have folded over? There's sort of, there's some issues. But the point of it is to plot the other side, you plot that point. Positive 0.71, negative 3.3. Positive 0.5, negative 4.5. Positive 5.65, negative 5. Like, the x value changes sign, the y value stays the same. Okay? So those of you who did not get to put one up, here's the odds. And for the odds, stuff trades. Let's see. Let me do this. If I turn it upside down, that's what I'm looking for. So the coordinate negative 2, 0 became positive 2, 0. The coordinate negative 3, 2 became positive 3, positive 2.
You just flip the signs.
So it sounds like you just need to flip the signs. So the graph, the coordinate 3, negative 2, 3, 2. So those of you who didn't get the graph yet, go for it.
You didn't cross it off. Bro, I said, let me get the 2-0 at the way, bro.
As a former captain. Yeah, but he's. I'm so happy. Oh, I'm happy. No, yeah,
Give me the two. There's two. We're at about half an hour here.
It's a culture thing.
No, it's valid.
Is that a mare or a sweater? You want to call
So
it?
it's just, how it feels like I'm invading.
Yes, so that's,
Wait, no, wait, maybe you're married and you have plans.
number states.
Are you?
It's like, you even have to get out of here.
What if, what if that? Does that look right? That does not look. What the? Knowing you're like, that cannot be right, bro. It's like, you plotted these points, bro. That's the point. Oh my god. No, but we're not cooking. We actually, we burned down the kitchen, bro.
Kinda? What do you think?
I go after the body.
I'm talking about that. It doesn't look bad.
Alright. So. No. See, there was the phone down. For a reason. So guys, when you come in, you are expected to put your phones in the phone jail. Because if you're on it, I'll take it. Okay, so even and odd, here's the thing. Can you do that on your own with this paper? Compare with the person next to you? I remember. What did she give us? Yep. There's tons extras. Okay, sorry, I'll be right there. Let me bring this back up.
What was the same?
I don't want to talk about it. Caney sounds longer than
Dude, I wish I could get like a cutout of this and like just put it.
Okay. Is Isla? The arrows point the same way. Is it even? If I fold this over, does it land on itself? No. So it very much, this is something that has a squared on it, it has an even power. but it's not an even function, because even functions are more special.
Wait a minute, is negative 2x, you add negative just 2x? No, with negative 2x, and you add a negative to x, that cancels
See the section off logical might or math calculus teacher.
What's that?
That was pretty
You already
good.
find the inverse on
She's pretty good.
What?
I want to see how you do it.
Oh, you wanna see how I do it? I'm gonna totally cheat. So I wanted it reflected. I am going to transform it.
That's technically not a fail.
See, I cheated.
Groundbreaking. Oh my goodness. This is double. The fact that it's not separated from the other groundbreaking technological advancements.
I worked there.
Oh, you did?
I did.
CIA?
You worked
Yeah.
in the CIA?
Yeah. I was a contractor. I worked at TRW, I was a contractor at CIA, NASA. And I said, oh yeah.
And you're a math teacher? That's weird.
Because if you don't, like, when you first get there, it takes years to get clearance. So they walk you around like you're on a.
Did you get the clearance or you left it?
I got the clearance after I left.
Oh, yeah, I watched.
Oh, with this gal, I have a question.
Yes.
What? My math teacher was a CIA agent.
Okay, hold on. Before we talk about the ones at the bottom, just
That's actually
okay, hold that idea. All right, guys. Looking around, a lot of you have the top two flash done. They look good, and you've already moved on to the bottom. So, all right. You guys agree? Odd. All I did was flip. I copied the picture and reflected it. For the even, and for the odd, I turned it upside down. Good? Okay, so great, you were asking about these guys. What's all the stuff you know about inverses? Do what?
That one you just make it negative.
What do we know about inverses? From Algebra 2. Yeah? It's the opposite. Like you do the undo operation, the opposite operation. The opposite of add 3 is subtract 3. Okay, what else do we know, guys, from Algebra 2? West sit up. What's the relationship of, let's see. If the function has the coordinate 0, 7, what goes into the inverse and what comes out of the inverse?
7.
So if 0 goes in and 7 comes out, the inverse operation has to take 7 in and spit out 0, right? So if I want you to graph this, the inverse of this function has the coordinate 0, 7. So the inverse is going to have 7, 0. What is another coordinate that will be on the inverse given this
So
one?
it's 3, 2, but then you flip it, so it's 2, 3.
So this coordinate, 3, 1, right?
3, 2. Or 2, 3.
Okay,
2, 3.
2.
I already flipped it.
Okay, so 2, 3,
And then turns into
3, 2. And 3, 1 is gonna become 1, 3. And I'm gonna cheat and use my line tool so it's more precise.
Oh, so we didn't have to write the inverse of the equation, just the,
Okay, we're gonna get there.
Oh,
I do
okay.
want the inverse of the equation, I'm just not there yet. So numerically, what we just did with a couple of coordinates was find the x, y coordinate on the function, trade the x and the y to get the graph. We okay with that? We remember that from Algebra 2? Okay. So Gray is saying, oh, so we didn't need to find the actual inverse equation? Yes, you did. And we would do that in the general. Instead of writing g of x, what does g of x stand for? Is it the x value or the y value? It's the y value. So to get the inverse, I'm gonna trade x and y. And guys, I'm sorry, I don't call it y. I'm gonna call it g inverse because I found you guys got confused when you solved for another y. There was this y and then there was another y. To make you not confused, I'm gonna use this g inverse because that's what I'm looking for. All right, gonna use some vocabulary here. Aiden, what is the inverse operation of +7?
-7.
-7. So I am going to undo,
You forgot the negative in the -2.
I forgot the negative on the -2, thank you. So I have x minus 7 equals -2 g inverse of x. Raul, what is the inverse operation? How do I undo this, whatever is that doing?
You divided by the same number, -2.
Okay, so to undo multiply by -2, I'm gonna divide by -2. So g inverse of x equals, I don't want it left like this. Okay. So,
Isn't there something specific that that form is better for?
not a lot, but
Okay. I just remember
not a lot.
something that's hard. You don't want to keep it a fraction?
Well, the fraction, okay. Here's the question. 1 plus 7, 1 over 7 plus 3 over 7, what does that become? Lorenzo, what does it become? 4 over 7. So what you did was you added them together, and because they're like terms, you got a 4 over 7. Okay, I wanna know, can you guys go the other direction? Subtracting 7 is the same as adding what? Adding -7. Okay. Dora, can you split this up? So right here, looking at this example, 1 plus 3 over 7 became 1 over 7 plus 3 over 7. How do I split this fraction up over here? Okay, what's the first dude up top in the numerator? The x. So x over this, over the -2 plus,
-7 over -2.
okay. So what this ends up being, negative over a negative ends up being positive, okay? X over -2. On an AP exam, or an SAT, or a PSAT, or a GRE, name your 3-letter acronym. How are they gonna write that? They're not gonna leave it like this.
One negative
They will most likely write it as -1/2 times x. Is that the same thing?
Yes.
It is, okay? So this is a straight line with a slope of -1/2. Looking at the green line that I graphed here, down 1 over 2, down 1 over 2, slope is -1/2. The y-intercept is 3.5. 3.5. So visually, I took the coordinates you guys told me would be on there and I drew it. Now, doing what Gray was saying earlier, trade the x and the y and solve for that y, which I'm gonna call g inverse. I got the equation for it as well. So I found the inverse, there it is. How do you undo multiply by -2 and then add 7? Well, you undo that by multiplying by -1/2 and adding 7/2. Okay. And for any given function, you guys said it folded over the y-axis. For an odd function, you said it spun upside down. Do you know visually what you check for to see if it's how to do the inverse? It folds over something as well. Y equals x. Good job. And so far, every class was nuh-uh. This brown, if it folds over the blue line, lands on the green. This brown lands on that green, if it folds over that slanty y equals x line. Kinda? How you doing, Teddy? Yeah, roar. There it is. Okay. Okay, I would like you guys to graph the inverse of this one. And there's some issues with it, but graph the inverse. So trade some x and y coordinates and graph them. I see a lot of you guys already have this drawn. Wes, tell me one coordinate that's going to be on the inverse.
2, -3, 2.
So -3, 2 is on the function.
Oh, yeah, but like, so it's.
So trade the x and the y. This was -3, 2, so 2, -3. Ella, what's another coordinate that's going to be on my inverse?
2, -7.
Oh, Ella and Bella. Sorry, I asked Ella.
-2, -5.
So 5, -2, so -2, -5. Okay, and Bella, you said which one?
I said 2, -7.
Yep. Okay. Zara, is my original function, well, this parabola, is it a function?
Yes.
Yes. Virginia, is it a 1-to-1 function? No, what? Oh, you were quick with that, so how do you know? Okay. So, guys, it is a function, Zara said, because it passes the vertical line test, we drag a vertical line this way, it only hits once. But Virginia said it does not pass the horizontal line test, it is not a one-to-one function because cutting slices that way, it hits twice. Okay,
This one's not a function at all.
so the inverse as drawn right now is not a function at all. It fails the vertical line test. This guy, if I draw a vertical line on these guys, hits twice, it's bad. So Byron, is there a way I could chalk this so that it is a function? So I'm gonna cut off the bottom part.
That's restricting the range, right?
Okay, it's restricting all kinds of things, but, okay,
So should we remove it too?
well. The inverse needs a restriction in order to still be a function. And what we're gonna be spending a lot of the time between now and the test is understanding what those restrictions are and how to apply them. So Virginia said again, this fails the horizontal line test. Right where it fails, right at that little turning point, if I cut it off there, and if I just reflect the thing that's in that box, I get the part that Byron was saying, that would be the function. Joseph, what's the domain of my original equation? Domain of f of x? All the numbers. Vasya, what's the range that comes out of the parabola? The lowest y value first. Does it include -2 or not? So square bracket around.
Where?
Square.
Yeah.
So it hits -2, so yes, include it, so yes, square bracket. Okay, inverse. The inverse that we drew. Usually we trade the x and the y, so maybe, let's see if this works. Domain is the x's, range is the y's. The range, does that become my domain? Looking at this, I'll do the x values start at -2 for my inverse. X is -1, x is -2.
Oh, no, it does.
It does. But the range, Teddy, do all the y values, does the domain swap? No, it got restricted. How? What's the new range? What's the lowest y value?
Square bracket -5.
Square bracket -5. This is tricky. Like to do this without, the graph is hard. But do you see the relationship that I had to cut it off to make it be a function? If you ask your calculator I will ask you guys are students, you are smarter than the calculator. Sophia, square root of 25.
5.
So if I said x squared is 25, x is 5, or -5. But if you're asking your calculator's just gonna go, it's 5. If you wanted the -1, you had to take care of that yourself. So it does a restriction. It can only give you one answer. But we're smarter than that, and we're like, oh, well, -5 works too. But to include the -5, it means you're gonna get 2 answers, which we didn't. We need to restrict for the computers. But now, to do the other piece, Liffey, if I wanna find the inverse, what do I need to do?
F -1.
I need to find f inverse, and it's, be careful, it's not to the -1, it really looks like that, but it's f inverse. So, I'm gonna say, trading the x and the y. Angel, undoing one step at a time. What do I have to get rid of? Oh, sorry, I wrote that wrong, didn't I? So I wanted F inverse of x plus 5. I want to get F inverse alone, but I have other stuff hanging off of it first. What do I get rid of first? The -2 by doing what? By adding. And now see, what do I do next? Square rooting it. Okay, now we put the square root in there. We should say plus or minus. That I want this to be a function. Do I keep both or do I only keep the positive? Okay. That I want it to stay being a function. When I say plus or minus, it gives me that bottom part's no longer a function. So I'm going to get rid of the minus. I still got stuff going on though.
Subtract 5.
Subtract 5. And there's my inverse. And the range, now if I looked at this, what's the smallest y value that pops out? Well, the smallest number that comes out of square root is 0 when x is -2. So the range is going to be -5 to infinity. Oh, I'm looking at that.
Yeah.
I mean, some of you see it, some of you don't. Domain, we're not allowed to do divide by 0. What else we're not allowed to do? Square root of?
Negative.
Negative. Can I do square root of 0?
Yeah.
Yes, square root of 0 is 0. Okay, so to find the domain, when is the stuff underneath equal to 0? When x equals -2. And anything positive. So the domain of my inverse was -2 and anything bigger. And the range, what are the y values that come out? Well, if I put in -2, that goes away. My lowest y value is -5. I got both things that I knew already by looking at the graph. Good morning. All right, so I want you guys to finish the worksheet as homework, which includes graphing these guys,
I know.
graphing the inverses, and doing those bottom pages.
Today I'm actually a little bit more tired. Like I couldn't say we can